Alright guys, before you do this homework, please stop this video right now, go back and watch my video on the laws of logarithms, right? So to explain this sort of thing. I don't want to have to re-explain it over and over. Watch that video and then come back to this homework and watch the video for this homework. Right, so I'm just going to assume that everyone's already done that and has watched the video, and so let's go through these things. So part A, the log of 45 times 68 is going to be the log of 45 plus the log of 68. Part B, the log base m of pq just equals log base m of p plus the log base m of q. Part C, log base 10 123 over 31 simply equals the log base 10 of 123 minus the log base 10 of 31. Part D, log base m of p over q is log base m of p minus the log base m of q. If this isn't making sense to you, go back to my video, please. And if it's still not making sense to you, then you need to write me an email. All right, log base 2 of 14 times 9. When I say go back to my video, I mean specifically the video I did explaining the laws of logarithms. All right, so that's going to be log base 2 of 14 plus the log base 2 of 9. Part F, log, I don't know why I have to do all of these. It's all the exact same thing. And that's just equal to log base 4 of 81 minus the log base 4 of 30. Express each of the following as a log of a product or a quotient. So we're just doing the reverse of the other one. So part A, this is the log base 10 of 35. B, this is the log base 3 of 2. Just here, I'll say, I'll go a little slower this time, of 4 over 2, which equals a log base 3 of 2. Part C, the log base m of a times b. Part D, log base 10 of x over y. Part E, log base 6 of 7 times 8 times 9, which is equal to the log base 6 of 9 factorial over 6 factorial. That's true, but I just did that as a joke. Anyone taking data management would know what that is. Log, so you can just ignore this, guys. I was just kind of being silly. Log base 6 of, what's that, 56 times 9, so 560 minus 56, so 504. And let's see, part F, log base 4 of 10 times 12 divided by 20, and that's going to be log equal to the log base 4 of 6. All right, let's go to number 3. Express each of the following in the form where you have something log of something to the base something. All right, I can do that. So part A, this is going to be 2 log base 10 of 5. Part B, it's going to be negative 1 log base 3 of 7. Part C, again, if you don't understand this, it's because you didn't watch my previous video. I encourage you to go do that if you are interested in learning this properly. All right, so I'm gonna take 2 steps for this one. Log, this is going to be 40. This base 10 because it doesn't say anything. It's 45 to the power of 1/3. Just in case you guys forgot that, so this is going to be 1/3 log base 10 of 45. And D, let's go E. So this is going to be 0.5 log base 7 of 36. and f is going to be 1/5 log base 5 of 125, which, by the way, just equals 3/5. If you're looking, 5 to the 3 is 125, so this right here equals 3, and so 3 times 1/5 is 3/5. All right, let's try question number 4. Use the laws of logarithms to simplify and then evaluate each expression. All right, so start A. So we got log base 3 of 135 minus log base 3 of 5, which is equal to log base 3 of 135 over 5. So that's equal to log base 3 of 27. And that is equal to 3. Part B. Log base 5 of 10 plus log base 5 of 2.5 is equal to log base 5 of 10 times 2.5, which equals log base 5 of 25, which equals 2. Part C. Log base 10 of 50 and times 2. So that's going to be log base 10 of 100, which equals 2. Part D. Log base 4 of 4 to the 7. Well, that's just going to equal 7. I could have said equals log, didn't leave enough room, equals 7 times log base 4 of 4, which equals 7 times 1, which equals 7. So 4 to the 1 gives you 4. So that's just going to be, this will just equal 1. Let's get rid of this stuff. Part E. Log base 2 of 224 minus log base 2 of 7 equals log base 2 of 224 divided by 7. All right, so 70, 140, 210, so this is going to be the log base 2 of 32, and that just equals 5, because 2 times 2 times 2 times 2 times 2 equals 32. So it's 5. And F, the log base 10 of 10 to the 1/2 just equals 1/2. Right? You could say, if you want to use your laws of logarithms, you could say 1/2 times the log base 10 of 10, which is 1/2 times 1, which is 1/2. But I think you should recognize if the base here and the base here are the same, that this is just going to be your answer. All right, this looks like it's going to be fun. Evaluate the following logarithms. Fun if you're into doing math for fun. The log of 25, the log base 25 of 5 cubed, that equals 3 times the log base 25 of 5, which is going to be 3 times 1/2, right? Because 25, just so you know, 25 to the 1/2 equals 5, which is the same thing as saying square root of 25 equals 5. Right, so this is just 1/2, and that is 3 over 2. There you go. Let's do part B. Log base 6 of 54 plus log base 6 of 2. So I'm just going to multiply this by 2 minus log base 6 of 3. So I'm just going to divide by 3. There you go. So that's equal to log base 6, 54. So this is 108 divided by 3, 36. And this is just equal to 2. 6 squared is 36. Part C. Log base 6 of 6 root 6. Okay, so that's going to be equal to log base 6 of, this is 6 times 6 to the 1/2. So 6 to the 1 times 6 to the 1/2, which equals log base 6 of 6 to the 3/2, 1.5, which just equals 3/2. Another way we could have done it is we could have said this is equal to log base 6 of 6 plus log base 6 of root 6, which is, this is just 1. Log base 6 of 6 is 1, plus, well, 6 to the 1/2 is the same as square root of 6, so this is plus 1/2, and that, again, equals 3/2. Right? 2/2 plus 1/2 is 3/2. Let's do part D. Right, so we got log base 2 of root 36 minus log base 2 of root 72. So that's going to equal the log base 2 of root 36 over root 72. Or we can rewrite that as the log base 2 of root 1/2. And that equals the log base 2 of 1/2 to the 1/2. Or we can say that it is log base 2 of 2 to the negative 1/2. And so that just equals negative 1/2. All right, there you have to remember that a negative exponent just makes it the reciprocal. Right, so if you do a negative exponent, you can switch this inside to 1 over. And 1 over 1/2 is just 2. You put the top on the bottom on the top. So that's a little trick that might make things easier for you. Part E, log base 3 of 54 plus log base 3 of 3/2 is equal to the log base 3 of 54 times 3/2. Oops, I should write 54 when it's 54. Equals the log base 3 of, let's see, that's 27 times 3, so 81, which equals 4. And part F, got log base 8 of 2 plus log base 8 of 2 cubed, right? So this 3 can come up here. In the same way that this 3 can come down there, it could also go back up and it'll still be the same. And so that's, I'm going to replace the 2 to the 2 cubed by just 8. There we go. And plus, same thing, 1/2 could just come up here, and 16 to the 1/2 is just 4. So log base 8 of 4. 16 to the 1/2 is 16 to the 1/2 is just the square root of 16, which is equal to 4. Right, there we have it. So this is equal to log base 8 of 2 times 8 times 4, so it's 64, which equals 2, because 8 squared is 64. Now I could have also recognized that this middle one is just equal to 1, and then this and this I could have put together as log base 8 of 2 times 4, which is another 8. Log base 8 of 8 plus log base 8 of 8 would be 1. Oops, these two together will give you 1, and this guy gives you 1 for a total of 2. Lots of ways of looking at it. Use the laws of logarithms to express each of the following in terms of the log of x base b, the log of y base b, and the log of z base b. All right, I think we could do that. So A, this is the log of x base b plus the log of y base b plus the log of z base b. Yeah, that was easy. Part B, this is the log of z base b minus the log of x base b minus the log of y base b. Right, the two on the bottom are subtraction, are going to give you a subtraction, and the one on the top is addition, so it's plus at the beginning. Okay, so part C, log of x squared base b. I guess I should say that's going to be log, this is the same as, here, let me just rewrite it. Log base b of x times y times y times y. So log of x base b plus log x base b plus log x base b plus log, oops, that's too many x's. Make that one a y. Plus log of y base b plus log of y base b. There you go. It's in terms of what they wanted here. Now I could easily have said this is equal to 2 times the log of x base b plus 3 times the log of y base b. Now here our answer was actually already complete right here. We already answered the question, but this just is maybe a tidier way to present it. Let's get rid of that and go to part D. So we got the log base b of x to the power of 5 times y times z cubed, all to the 1/2. And this is going to be 1/2 times the log base b of x to the 5 times y times z to the 3. And we can write that as 1/2 times 5 log x base b plus log y base b plus 3 times log z base b. Part 9, write each expression as a single log. All right, I can do that. Let's go A. This is a log base 5 of 2 to the power of 3 times 7. So that's log, I can say it's also equal to log base 5 of 8 times 7, so 56. Part B, log base 3 of 8 squared, so that's 64. Oops, I should have put that a little higher here, leave myself some room. 64 divided by log base 3 of 2 to the power of 5, which is 32. So this is log base 3 of 2. Part C. So this is equal to log base 2 of 3 squared, which is 9, times, so base 2 again, times 5. And that's just log base 2 of 45. Part D, log, okay, this is equal to log, looks like we're going to have a base 3 of 12 times 2 divided by 6, which equals log base 3 of 24 of 4. Part E, log base 4 of 3, so 8 to the power of 1/2, so root 8 we can say. So that's times root 8 and divided by 2, right? Now root 8 can also be written as log base 4 of 3 times, this is root 4 times root 2 over 2, which can also be written as log base 4 of 3 times 2 times root 2 over 2, and these guys cancel. And so this is equal to log base 4 of 3 root 2. There we go. Part F, we got this is equal to the log base 10 of 8 squared, which is 64, times 9 divided by 36, which equals the log base 10 of, this 36 could cancel with that 9 and become a 4. Now it can cancel with this and become a 16, so just 16. Number 10, use the laws of logs to express each side of the equation as a single log, then compare both sides of the equation to solve. All right, let's first make them all single logs. So we've got A, we got log base 2 of x, that's already a single, equals log base 2 of 7 squared, which is 49, times 5. So we can say log base 2 of x equals the log base 2 of 49 times 5. 50 times 5 is 250, so 245, which means x just equals 245. For these two to be equal, obviously x has to be that. It's pretty easy. Part B. Log base 10 of x equals log base 10 of 4 squared, which is 16, plus log base 10 of 3 cubed, which is 27, but I'm not going to write in log base 10 of 27. I could just do times 27 here. And so x just equals 16 times 27. Well, 27 times 10 is 270. So times 15 will be another 135. So 405 and another 27. So 432. All right, part C. Log base 4 of x plus log base 4 of 12 equals log base 4 of 48. All right, let's get this left side as, no, you know what? Let's bring, what does it tell us to do? Use the laws of logs to express each side of the equation as a single log. So I guess I have to do that first. Now, of course, the smart thing would be to bring this guy over here and keep the x by itself. But that's not what it's asking us to do. It wants us to put them together first. So we're going to say this is log base 4 of 12 times x, so 12x, equals log base 4 of 48. So now we can say 12x equals 48, and now we could divide both sides by 12, and you're going to get x equals 4. So just so you guys understand what I was saying before, I would have done log base 4 of x equals log base 4 of 48 minus log base 4 of 12. I would have brought that over first. And so we could say log base 4 of x equals log base 4 of 48 over 12. And so x equals 48 over 12, which is 4. So you'd get the same answer. It actually didn't make it that much easier in the end. Perhaps it didn't make it easier at all. All right, so part D. Log base 7 of x, that's already a single term, equals log base 7 of 25 squared is 625 minus log base 7 of 5 cubed, which is 125, but since it's minus, we're just going to go over 125 here. And so x equals 625 over 125, well, that's just 5. Part E. Log base 3 of x equals log base 3 of 10 squared, which is 100. And same base here, so over 25, because that's a subtraction. And so this is log base 3 of x equals log base 3 of 4, so x just equals 4. Part F. Log base 5 of x minus log base 5 of 8. So I could just say x over 8 here. Since it's the same base, we can use our rules, and that's going to be log base 5 of 6 times 2 cubed, so times 8. And so x over 8 equals 6 times 8, which is 48. And so x equals 48 times 8. 8 times 50 would be 400. So 8 times 48 must be 384. Number 11, write each expression as a single log. Assume that all the variables represent positive numbers. Okay, that's important to say because if you had a variable that is a negative number, such as u here, you can't take the log of a negative number. We have to remember that. That would be out of our range. So let's go A, and we want to write it as a single log. So we can say the log base 2 of x, y, z in the first one. Part B, log, they're all base 5, of u over v times w. uw over v. Part C, we got log base 6 of a minus, minus all of this. So it's like you take away the first one, so that means the b goes on the bottom. But also we're taking away this next one, right? This minus, you're subtracting both of the things that are in these brackets. So it's also minus the log base 6 of c. And so b and c will both go on the bottom. All right. Part D. We're doing the log base 2. We've got x squared minus xy, so there's going to be an xy on the bottom, and plus y squared, so you're going to have a y squared on the top, and that's just equal to log base 2 of one of these x's is gone, one of these y's is gone, of xy. Part E, this is going to be log base 3 of 3. I'm trying to get that 1 as a logarithm, so what log base 3 of 3 will do it. That's just equal to 1. And plus log base 3 of x squared. So we could say this is the log base 3 of 3x squared. And then we get f. So I just want to reread, right? Each expression is a single log. We did that. Assume that all the variables. Yeah, okay, that works. F. This is going to be the log base 4 of x cubed, right? This 3 can come up here. Plus, so this is going to be times x squared, and divided by y. Okay, so that's just going to be equal to log base 4 of x to the power of 5 over y. There, that's it.